All right, we have one last video here, one last example on synthetic division. If you're coming in out of Algebra 2 and you're not watching my playlist, maybe you watch the whole playlist together. I'll give you a better idea. You can go watch the other videos with lesson 5-7 dealing with synthetic division so you understand the process first. One last example. This will be a quick video because we're just going to walk through the problem. Ready? I'm going to start off by drawing my half box. Okay. The numbers that go in the top row would be 3, -4, -28, and -16. Remember, one more time, I'm just going to keep saying it over and over again. If you have a power of x that's not represented, like if this 28 didn't exist, if it just went 3x cubed minus 4x squared and then minus 16, if that term didn't exist, we would have to put a 0 in this location for the x's, right? It needs to go x cubed, x squared, how many x's, how many constants. The number that goes on the outside of the box here would be, I look here, it's x plus 2. So I flip the sign, I got to put a -2. Now, we always drop the first term down. You're going to add vertically. 3 and nothing to add to it would just be 3. I take these two numbers, 3 and -2, I multiply them together, -6. So -6 goes up in this spot. I add these two terms vertically, -4 and -6 add up to -10. I multiply these two together, -2 and -10, add up to +20. Be careful about your signs, right? I add vertically, -28 and +20, add up to -8. I multiply, -8 and -2, add up to +16. And then I add vertically, -16 and +16, add up to 0. 0 is the remainder. So, if these are my x cubes, that means these are my x squareds. I have 3x squareds in my answer. If these are my x squareds, that means these are my x's. So I have -10 x's. If these are my x's, that means these are my constants. This is the no x at all, right? And so, -8. I don't have a remainder, which is awesome because that means on every other problem we've had a fraction at the end. This one doesn't have a fraction. It's +0 over something. So, I mean, why write it? There's no remainder. That means a lot of things that we're going to get into next time, okay? When we have 0 for a remainder, that turns out to be a pretty spectacular case. That means, really, that's the same as like if I did 21 divided by 7 with long division. I would say, well, it goes into it 3 times. 3 times 7 is 21. I flip the sign and I subtract and I get 0 for a remainder. You know what that tells me? When I have 0 for a remainder, that means that 7 goes into 21 evenly. So the crazy thing is, x plus 2 must go into this thing, must go into it evenly, just like 7 goes into 21. And that tells us all sorts of information. That's what we're getting ready to get into with this next set of problems. That's what we're really working on in this chapter with polynomials. So that's cool that it worked out that way. Hopefully you understand the process of synthetic division and you're ready to work on some homework problems with me in class.